Ay, ay, ay. What the heck just went on there? All right, you guys are still with me, right? Daryl, Mark?
I am still here.
Yes, yeah.
Okay, very good. All right, let's see. Is this the old stream or the new stream? Hold on here. Live. Let me click that. That has to be the old one. Okay, so this is the new one. Is it? Or, well, hell if I know. Let me find out here. Okay. Yes, okay. So that's the old one, this is the new one. Let me test to make sure we got...
So does it give you, like, you have to have a... oh, because he's showing the same thing, you don't know if it's...
Yeah. So
gotcha.
This is... Oh, no, sorry. What the heck is going on? Why is it... Oh, this is weird. Click live. Skip ahead to the live broadcast. Oh, I'm just about a pain in the butt. I'm trying to figure out which one's the live one. Okay, let me shut that down. Okay, now it's saying we're live. Stream health. Okay, so let me take that.
21 people watching. Is that what the one that says it?
Advanced settings. Boy, that was weird. I
never
had that do that before. I'm gonna label this one. I'm gonna label this one part 2, just so we know the difference between the two.
There you go.
Ay ay ay. Okay.
Hey, look, Keith's ability to handle crisis is legendary.
Yeah, right. All right. It looks, but we'll see. We're still frozen. Why does it keep taking me to the old one? Well, Amanda just told me that we're live somewhere. I can't find it.
I see live and loud is what I'm seeing. But what we're looking at on the screen...
It's frozen, right?
Well, no, the time is going by. Is that just an overlay and the image is frozen?
Your guess is as good as mine. Because right now that clock should say 11:45, probably like right around the time. So it should be like right at 11:45:01.
It does.
So why is it so dim?
It's not dim. Oh, well, what do you mean?
Like the actual image is dim. Let's see. Amanda just sent me a link, so let's see if
I don't see it dim. I see it. Maybe I'm looking at the right thing and you're not.
That's possible.
But I'm also not seeing any shimmering, indicating this is a live view.
Exactly.
Oh yes, I am. No, I am. I am seeing it. It is a live view. It's just that Paul's not touching the telescope.
I'm gonna put my mouse on there, just wiggle it around on the screen. Let's see if it shows.
Okay, I can see this is a live view.
Okay, Amanda just sent me a link, so let me try to get that. Oy vey.
Hey, come here. Oh, I just saw a bird fly by.
Yeah. Let me enlarge.
Ah, boy, here comes that old Andy again. Hey, come here. I see you wiggling your mouse, by the way.
Okay, yeah. So that's working. Okay, we're good. We're back on where we need to be.
Yep, we're there.
Jeez Louise. Anybody wondering what happened there? We have absolutely no idea. It just all of a sudden cut out and OBS quit working, and I hope we all can be still heard. So we'll do a volume check. So if you can hear me, that's awesome. If you can hear Mark is here, right?
Yeah, no, they did say live and loud.
How about Daryl?
I hear you guys. I'm not sure it's working on the stream though.
Let me see. I'll check it real quick.
I just cheated and turned on the sound to the live stream. Didn't hear anything.
Yep, it's working.
Yeah, if you guys have Danny fan. Amanda says it's live. I promise.
Yeah, it's there. So sorry about that, guys. It just everything just went kaputs all of a sudden, and now
it was all Keith's fault.
Yeah, it's probably all my fault. I wouldn't doubt it. So yeah, sorry for the interruption. This will be renamed Part 2 if you're watching it tomorrow or something.
Relax, guy. Sit down. Take a load off. Look over here.
that was crazy. First time it ever happened. So yeah, where were you guys at?
We were talking about gravitational waves, man, and we were explaining how the Virgo detector was detecting it along with the LIGO system. Virgo was sort of a missing link, though, that with the Virgo detector being able to detect gravitational waves, that it gave us 3 points. And that means that we could actually pinpoint where this gravitational wave came from with a little bit more accuracy than a 2-point analysis.
And then Mark mentioned some advanced alien species like weaponizing gravity waves or something similar. And that led me to talking about the Kurzgesagt channel on YouTube. I posted it in the chat stream. I will post it one more time. Plus, I also have it subscribed at my website, at my YouTube site, if you want to look. Kurzgesagt, I believe it is, Kurzgesagt. They talk about all sorts of fanciful ways to destroy the Earth or to destroy the entire universe, for that matter. Advanced alien species, all sorts of neat stuff. It's a really cool channel, and I highly recommend it if you ever want to watch it.
Well, Daryl, there's one way that I talk about, and I do these talks, at these different conferences. One of the things I mentioned, I mentioned that in 1994, I talk about Miguel Alcubierre's warp drive that he designed and postulated, and of course. And most people in the chat now know from talking to hearing me talk before that the Alcubierre drive could never work as such now with our current technology level because it requires the equivalent mass of a planet like Jupiter being converted to pure energy in order to create this warp bubble. And of course that's just silly. It's too much, and even an advanced species wouldn't go that route. But when scientists at NASA redesigned the toroidal ring around the hypothetical ship's warp generator, basically, they found they could reduce the amount of the energy required by 10 to the 26 power. That is to say, in real-world terms, from something the size of Jupiter converted to energy to something the size of the Voyager spacecraft converted to energy. Yeah. That massive reduction, Daryl, is the reason why it became something that NASA is now investigating. But there's a caveat, and that is that just like, as we see with our cars driving down the highway, a long highway, if you're going through space, using the Alcubierre drive, the way it works is, of course, you compress the distance between you and your destination, and you lengthen the distance between you and your origin. And you actually traverse the distance without actually violating any of the laws of the universe, which of course includes a big one, the speed limit, which is 186,000 miles per second, the speed of light. And light travels fast, but not fast enough. I mean, that's 7 times around the Earth in 1 second that light travels at that speed. So at that speed, which is hugely fast, the sun is still 8 minutes away, okay? And the farther planets are still hours away, in our solar system. So, but as you're traveling from one place to another with this Alcubierre drive, the warp bubble on the front of that warp bubble, just like as you're driving down a highway in your car, it gets bugs on the windshield. That is, charged particles that hit that front of that warp bubble, and they stay there. And then if you stop abruptly at your destination, the warp bubbles shut off, and where those particles go? They go everywhere. Okay, they destroy the solar system. They're so powerful, they will destroy any solar system you enter if you just go in at full power and just like shut it off. Boom, pop, boom. Now, that's not very economical, and I've made the joke before that if you're standing there with your friend and as you're starting to come out of the Alcubierre drive warp, you see that Proxima Centauri has a full burgeoning civilization with lots of space stations and massive infrastructure, all kinds of things going on. But then you shut off your Alcubierre drive and say, wow, Proxima Centauri's got like an advanced race here. All of a sudden, this wave expands from your ship and boom! It wipes out Proxima Centauri, the star, wipes out the planets, it wipes out the civilization all in an instant. And then you and your buddy would look at each other and say, let's tell them we didn't, we'll just tell them we didn't see a thing. Yeah,
Right.
nothing to see here, guys. We're coming home. And you sort of tiptoe out of the room, kind of a thing. Well, that process, that process of that leaching off of this energy has to occur long before you get to a system. And we're trying to figure that out now. We make it a 2 or 3 week trip, and it's a little better because then you can slow down gradually. Now, keep in mind that explosive energy that's released could also be the largest bomb ever created by a malevolent species here in the universe.
Of course.
You could send it at full power to your homeworld, the people you don't like, and just totally obliterate them.
Fascinating.
So, another object just went by.
Sounds like we need a warp windshield wiper or something.
Hey, Daryl, let me ask you real quick.
That's right.
How did you actually get into astronomy yourself?
Lifelong interest in science. I can think back. I've heard Mark talk about when he was a child. When I was a child, and we'd go to the library downtown. It's a cool old Carnegie Library, big old stone column building and all that, Well, I'd go down in the basement where the kids section was, and what really drew me was the books on science. I can still visualize one. I cannot for the life of me remember the name of it, but it was like a child's introduction to science, and it had everything from dinosaurs to astronomy in it, and that sparked my interest in science in general. I have to say, a lifelong interest in astronomy. The earliest thing I think I saw and figured out what it was, I believe it was called Comet A.K.A Secchi back about 1965. That I went out one night and found it and looked at it after sunset. And that was probably the genesis of, me really trying to do something in astronomy.
Interesting.
Now, what's interesting about that, Daryl, for me, it was Comet West. I was 5 years old with A.K.A Secchi, okay? But Comet West I saw in all its glory on the horizon at sunset, and I was just amazed. And I was 9 years old when I received my first telescope, and I had heart surgery. I had a heart defect, and they corrected it. And what do when you got to sit home and relax? Because back then, they didn't know what to do with me. They moved me from school to school so that I wouldn't have to climb stairs. It's like so ridiculous. Nowadays, it's so different. But anyway, I ended up getting a telescope, and I ended up going outside, looking up, and seeing the sky, and I was like, wow, those are cool. Those are stars. And from the earliest point, I was able to look at the sky and think, I'm seeing that as it was way back then. I'm seeing that as it was, just a couple of seconds ago, the moon, just over a second ago. I'm seeing this as it was 1,000 years ago. And I was consulting my books, and I put together that it takes the light. Light speed was the limit of the universe. I knew that. And I put together the fact that we're looking at a time machine by looking out in the universe. It was always a time machine.
Absolutely.
And I was hooked from day one on that. And I just started looking at things. And I actually had this vision of actually being able to find something in the universe that was actually reflective, that was, several hundred light years away from the Earth, and looking at the Earth's reflection in it and seeing the Earth as it appeared back when that reflection, was emanated, And if it was like, 1,000 light years away, we're looking at the Earth 1,000 years ago,
And let that be a lesson to any parents that are listening. So many astronomers got their start by a family member or a family friend getting them the gift of a small telescope, say for Christmas or their birthday. Many of astronomers have been turned on to astronomy that way, just by a random gift of where they didn't know they were actually into astronomy until they got that present of a scope. Even if it's a small, $50, $60 one, from Walmart, that's all it needs to kickstart that interest. And I really do believe that, we are in dire need of more astronomers, and
Absolutely.
it is the future. And, You know, so if you're thinking about a gift for anybody, especially a child, anywhere, you know, from 8 years old up, I would suggest, you know, a telescope for them and see if the interest takes off and runs with it, you know.
And you don't need a big one, Keith, you know,
Exactly.
to do this.
Yep.
I got my first one was just under 2.5 inches, you know, objective lens. In the end, it was a refractor.
Mm-hmm.
Okay, so all lenses. The light is progressively focused down to a point where you look at it through the eyepiece. And yeah, you learned early on you don't look at the sun. Obviously, you just blow out your eyes before you can even move. And so it was called a 2.4 inch refractor. It was a wonderful thing, and I used that thing every single clear night. Even in the middle of the winter, I'd be outside, and it was such a cool setup because it had all these levers on it and all these things. And I felt like a real scientist sitting out there with this telescope, and I feel like Herschel. You know, where I felt like Galileo looking through his optic tube. I felt like, you know, Isaac Newton with his, you know, making discoveries with his telescope that he had, actually. He had a small reflector himself, actually. That's what the Newtonian reflector.
Right.
And
Mark, was yours was it a Tasco?
It was a Tasco, and it was actually it was bluish. It was a blue color.
Tascos actually used to be pretty decent scopes back a long time ago.
Yep.
Oh, yeah. I have to caution people, though, if you go looking at telescopes at Walmart or department stores, if it's a standard 60 millimeter refractor, and if it screams 600 power magnification on the box, run, don't walk as fast as you can to get away from that telescope because it's junk.
Yeah, and I also have to say that the reason why I support Celestron so much, and once again, this is not a paid video, they're not a sponsor of ours right now, but Celestron put out 2 scopes that have won Scope of the Year many times, and that's the 114 and the 130. Now, these are pretty, I wouldn't say, I mean, they're amateur scopes, obviously, but I think they're 4.5 or something like that round, and I still use mine to this day. I mean, it's one of those scopes. It comes with a nice little kit, and it runs for about $150 or $160. But the parts in it are really good. The lenses are good. They're not crap. You won't see any plastic, you know, lenses trying to pass off as glass. And I do highly recommend, if you're going to get a first scope and get into it. Now, the 114 is not computerized. It's not a go-to scope. It's a regular old, you know, lat longe bearing, twisting the nips, as I like to say, with the one, getting them in focus.
Thanks for that picture.
But if you're looking at anything in our solar system, whether it be the Moon, Jupiter, Saturn, that scope, that 114 that I have, is amazing for that. It gives you beautiful pictures of stuff in our local solar system. So if you're looking to get started or getting some kids' interest in astronomy, that is definitely one I'd highly recommend when it comes to Celestron. Now, I haven't used many products from Meade. Mark could probably, you know, point you in the right direction when it comes to Meade. But when it comes down to Celestron, if you're looking for a first and or second scope, I cannot recommend the 114 or the 130 high enough.
You touched on something interesting there where, well, nowadays, again, everything is digital, and everybody, if they get a telescope, they want to get a go-to telescope. That's well and good, I guess, if it's going to get you out looking at things. But I'm old school. Mark is old school. My first scope, again, it was a 6-inch f6 Edmund Scientific Reflector, a Newtonian telescope. It was before go-to, okay? It did have setting circles. It had an equatorial mount, and it came with a copy of the old Edmund Scientific Mag 5 Star Atlas.
Oh, yeah, I had a stack of those.
I have at least 2 copies to this day. I love that book. I love that atlas. It is a great beginner's book. The scale will not overwhelm noob astronomers. There's a lot of other good information in it. But using that is how I got started. And I found my way around the sky using that star atlas and the setting circles on my telescope. And after a while, when I became familiar enough with the sky, I just knew where to point the telescope for all my favorite objects.
We call it star hopping.
Right.
Star hop from one
Star
to the
hopping.
next. Yeah.
Nowadays, well, all these telescopes come with go-to systems. Some are good, some not so good. If they get you where you want to go, that's great. But my concern with them is you will never learn the sky using a go-to telescope. You'll learn how to operate that go-to system just like, using a computer. But you'll never learn how to star hop and how to find your way around the sky.
Yep. And that whole...
That's true. I don't have
I
the
own
same...
go-to telescopes myself.
Yeah.
I don't have the same reservations as Daryl does because for what I'm doing, I'm actually dependent on getting the telescope as quick as it can from one place to another.
Yeah.
And so I actually do...
What's that old thing they used to say? You can never really appreciate astronomy until you have to do the meridian flip.
That's right, with an equatorial.
Yeah.
Now, see, again, my observatory, the telescope sits up, it's above your head, and it's actually a 10-inch Meade. It's a Schmidt-Cassegrain. And so, you don't have that problem with meridian flip with that kind of mount. And I prefer that. I know I don't want to have to do that maneuver. There are certain mounts that are really nice. Now, for instance, and Keith, you got your friend who's got the satellite tracking software. I still want to do that. And I'm also going to add a meteor radio to the observatory, to the SkyTour live stream, so that during the stream, if a meteor comes in, you'll actually hear it because it makes a burst of electromagnetic interference that you'll hear. And we're going to have that a live meteor radio in the SkyTour live stream soon. And that's a cool thing.
Mark, is your scope? I'm sorry, is your scope set up equatorial or alt-azimuth?
Yeah, let me just explain the difference. Alt-azimuth is like say you have a pair of binoculars, you just hold it up to your eyes, you just turn to the right and to the left and look up. That's you're doing things using your local landscape, your local horizon as your 0 point, and looking up in the sky. At the top of the sky is 90 degrees for you, and then 0 is down low, looking horizontal. If you mount it equatorially, now your point of reference is the North Pole. So it's as if you're laying back on your back if you're up in the northern hemisphere, or laying on your back pointing at the South Pole, at some angle, if you're in the southern hemisphere. And now when you look up at the sky, at some point when you're looking straight out, or at some point in the sky where you come up from the horizon up, you're going to reach the celestial equator, the 0 point. And then you can look to the right along that line and to the left along that line, or higher and lower. And my telescope's mounted that way. So my scope sees the sky not as you would with a pair of binoculars, but as you would in a like a typical observatory instrument setup, where you would actually follow the sky. In other words, if you're looking with binoculars and you're watching an object like a satellite, you have to move with the binoculars. If you're just staring straight out, you have to move your eyes up, catch the satellite, and then as you move to the right and follow the satellite, you're not just moving only to the right. You're moving up a little bit and to the right as the satellite goes by, say if it's moving from left to right. And you're basically doing a complex movement where you're kind of going on a diagonal as it's traveling across the sky, perhaps. That's something that you would still do if you're looking for satellites with my telescope. But if you just want to look at stars and track the stars, you only have to move one axis. You only have to move the one that moves from east to west, the right-left axis in the equatorial position for the telescope. And this way, all you need is a little tiny motor that drives that axis at the rate that the Earth is rotating out from under those stars. And so the telescope, over the course of a night, will simply look like it's moving, toward the west. As an object, if you're pointing at an object, it just looks. The telescope will sort of drift down toward the west and eventually point down below the horizon and keep going if it could, because it's following the Earth's rotation. And with a telescope that's mounted in that equatorial position, like mine, that's the only thing I have to care about. In the alt-azimuth position, then which the telescopes can also do, In the alt-azimuth position, they have to move over and up a little bit or over and down a little bit, one way or the other, constantly. That doesn't work when you're trying to do photography, because photography is dependent on a stable telescope system and, most importantly, stable guiding. That is to say, right, exactly, Daryl. So you know what I'm talking about. And the stable, and for the folks listening, stable guiding means you want to keep the star at exactly the same spot. And if that star has a nebula associated with it, a cloud of hydrogen gas or something you're trying to capture, you have to keep that right there in the same spot in the eyepiece for as long as you can while you're taking a photo. It can be a time exposure, like many seconds or many minutes and even hours. I've taken photographs for hours when they were hours long, each exposure in big observatories. It's not easy, when you have to guide it yourself, and some of these I did. And guiding it yourself means that you actually are looking in a crosshair that's faintly illuminated, and you have a guide star. That guide star is right there, and right between the vertical line and the horizontal line, right on the crosshair, right nearby, and you have to keep it there all the full time of the exposure. And the quality of how well you do that determines the quality of your final photo. If you're doing it for an hour and you lose it at the 45-minute mark, the whole exposure is ruined. Yep. So that's doing it the manual way, and I've done plenty of those. Now, I actually have this unit, but I haven't installed it in the telescope. There are auto guiders, which actually you put them on the telescope. It's a separate little telescope itself. You put it on the telescope, it finds the guide star, it guides the exposure, it takes care of making sure that the stars stay lined up properly. When the telescope, which does it also, it has some error that creeps in, and over time, you might find that your stars are making a weird little motion to the left and the right, or a little bit up and down, and it's because of what's called periodic error, and that has to do with all kinds of problems with mechanical systems meant to keep track of the stars. If we can get something that's perfect, then you get a beautiful exposure. If you can't, then you get trails, and you ruin a good exposure. Auto guiders take that away from having to do it. Now, in the old days, we looked through eyepieces in a telescope as well. Well, the Sky Tour Livestream Observatory, John Zach Memorial Observatory here, that observatory doesn't have an eyepiece. There's one eyepiece in the building, okay? And that's used for just when I want to just look at something and just do a test. Most of the time, I'm pumping the image out through a cable, through the camera on the end, the high gain camera, and it goes right to the screen. And we're watching everything that it appears in the view of the telescope is on the screen, TV screen.
Do you have to use a focal reducer for yours, Mark?
Mine's already an f6.3, so I don't use a focal reducer.
Oh, okay.
I neglected to mention that. It's an f6.3 10-inch telescope from me. Yeah, so it's wide angle, but what that means to the folks listening, when you look at a telescope, they're known by their focal length, and then you have an f ratio. That basically, the lower the number, the faster optically it is. Okay. The Meade 10-inch f6.3 is faster than the Meade 10-inch f10 telescope. All right, so the larger that number, the slower the optics is, meaning you'll have to expose longer to capture the same object on a 10-inch f10 than you would on a 10-inch f6.3. And so that's what I do. And so the f6.3 was a hard choice to make. When I started this project with John Zach, which is whom the observatory is named after, the idea was we're building a remote observatory, and it was going to be available on the internet, so people can come in, log in, take pictures, and that's kind of a cool idea. But he and I were going to do it together, but unfortunately he died from cancer. And so I basically, as a memorial to him, I named the observatory after him. And of course that's, he deserved it. He deserved to be memorialized that way. But this whole process of pumping an image to a screen rather than looking through an eyepiece is how we actually preserve it. We actually can do research with it, because modern observatories where they're doing research, there's no one looking through eyepieces anymore. And Daryl will agree with me that that's kind of sad.
It is.
Because they lose out on that wonder of seeing a deep sky object for the first time in a view. But if you see it on a TV screen, like we're seeing the moon here, not to take away from it, it's beautiful. Everyone gets to see it. It's a new medium. It's a different medium than astronomers in general have been used to, because the medium has pixels and not your eye, and that changes how we see things. The eye sees. What's the matter? Am I going too long, Keith?
No, I'm fine.
Oh, well, I thought you. Well, you were going. You were going, and I thought you were just like, oh, I thought you were saying,
no, that wasn't me.
Please shut up.
I wasn't even near the microphone.
You know, Mark, what you just said, yes, I find that sad in a way. I mean, digital cameras are great, and all the technology is great, but gosh, where's the looking at it? I have maybe mentioned before that before the August 21 solar eclipse happened, I read somewhere, don't bother trying to take pictures. It's only going to last 2.5 minutes less, or maybe a little more, depending on where you were. There are going to be plenty of people out there taking pictures and videos of the eclipse. For you as an individual, just go look at it. And I did. I wound up in northwest Nebraska, north of Scottsbluff, out in the middle of nowhere. I was just a couple of miles south of the midpoint of totality. Everybody had the same idea. There must have been 100 people on this roadside in the middle of nowhere, pulled over, set up. Everybody had cameras. Everybody but me. Well, I had a camera, but I didn't bother taking any pictures of the eclipse. I had a 5-inch Maxitov telescope with a solar filter on it. Turns out I was the only person there with the telescope. So everybody got to look at the partial phases through the scope. Thought it was really cool. But when totality occurred, I watched the whole thing naked eye or through the binoculars. What I saw, no picture, no video could ever do it justice.
Right.
I've seen all the pictures. I've seen the video. Just to be there and experience it, the wonder of it, the beauty of it.
It almost feels like an atmosphere kind of thing just around you, just the way everything dims out. And
absolutely, it was. Absolutely.
Did you see the eclipse bands? They're called eclipse bands. They're
the solar snakes.
Is that what those? That's another name for them. They're basically
on the ground.
Scientists don't really even know why they really occur, but it's probably some type of fringe interference pattern caused by the moon nearly covering the sun. And once it gets there, just before totality, anything that's like a broad white surface or single colored surface looks like it's shimmering with these linear lines on it, and no one can explain them, but they're called eclipse bands. And some people are known to get sick from them. Did you actually see any of those?
No, I didn't. Frankly, there was nothing flat and white close to me. There was a highway out in the middle of nowhere, and there was sort of high desert terrain. Nothing white, and doggone it, I was too darn busy trying to look at a half a dozen different things at once.
Oh, I betcha.
In the last moments before totality, I was facing west, hoping to see the shadow come rushing at us. Now, I sort of did, everybody sort of did, but it wasn't what I was expecting. Just you could see it coming, but it's not like you saw a shadow moving toward you. It just looked really strange, and it was red, it was purple, it was blue, it was bizarre, and it was beautiful.
The shadow bands are an interesting thing too.
Yes,
I wish you could see those.
That's one of the two things on my bucket list. I had a solar eclipse, and then the other one, which I still have yet to do, is there's a little town on the equator that every summer solstice, this town doesn't have shadows. because it's direct, and I just want to go there. And they said it looks so freaky. Like you don't really, your mind is programmed just to see normal shadows with basic things every day. And there's one day there's no shadows on anything.
Right.
And you said everything just looks so weird because
Yeah,
the
it
sun
probably
is
doesn't look
directly
real.
above. Yeah, exactly.
Yeah.
And I want to go there one time for that. I think that'd be pretty neat.
I've seen pictures of that in Hawaii, where they're below the line of the tropics. Zero shadows. There is so much out there to see, just to see, that I hope people don't lose sight of that, or get the chance to see it once in their life. So many people nowadays are stuck in big cities and never really get to see it. It's out there. I used to belong to the International Dark Sky Association.
Yeah.
I beat the drums for the IDA here in town 20 some odd years ago. Some people gave me credit for getting the city to switch to low pressure or switch to full cutoff sodium lights. Right, on city streets. And they did. I'm not going to take credit for it. Some people gave me credit for it. Did it help? I don't know. Probably not. Commercial lighting is totally out of control here in town. I used to be able to see the Milky Way from my front yard, and I can't anymore, just because when I moved to this neighborhood over 25 years ago, there wasn't anything out here, and the city's grown up around me, and a commercial corridor is just a block to my east, and they have lights out the wazoo now. And so I can't see the Milky Way anymore unless I want to load up the car and drive an hour or two out of town.
Is that how far you have to go?
That's sinful. That's why I want to move to Arizona, because they have dark sky rules and law. You can't install a high pressure sodium vapor lamp. You can't install lighting of any kind that is on the ground looking up. You just cannot do it. It's illegal, And Arizona has just a huge number of observatories, So they enact this dark sky rules within Arizona, and guess what? Connecticut, my silly state here, which I can't wait to get out of, has also enacted dark sky rules, and you can't install any new lighting that isn't full cutoff. And for the people in the chat, a full cutoff fixture is one that aims the light only downward and doesn't allow any light to spill to the side or go up into the sky, because that contributes to light pollution. And light pollution has been recognized as a very real nuisance and a problem that affects people's health. And it's been shown that a dark, starry sky is actually it's an ecosystem of its own, and the sky environment, being an ecosystem, is now protected by federal law in a lot of states. I think that's really cool.
Yes.
So basically what we're telling you people is we love bringing you the moon and everything, but if you have a chance to get outside and you're able-bodied to do it, do it. If you get a chance to do it or get to drive outside of the city, go for it. You won't regret it.
When I was in Wyoming a couple of weeks ago there, it rained for the first 2 days I was there, but that was good because the big Montana fires were burning, and Devil's Tower was actually shrouded in smoke, and it was hard to see. And your eyes burned for a couple of days. But after it rained, the blue sky was just absolute clarity. It was gorgeous, and then it cleared up. And I only drove a mile outside of Hewlett, Wyoming, and a bunch of friends followed me out there. And when we looked up at the sky, it was stunning. It made you, and then I said this before. I looked up at the sky, and I could feel my eyes tearing up because it was just so beautiful. And it wasn't because it was cold and windy. It was just an unbelievable sky, and it just and see, that's the thing out there, even in downtown Hewlett, right? If you look at the dark sky map, and there is something you can look at, by the way, for the United States, you can look up the dark sky map. And there's an interactive one where you can actually go see the light for your town, see how your town fares. And there's a scale called the Bortle scale, B-O-R-T-L-E, Bortle. And the Bortle scale measures light pollution. And that light pollution is measured on a numeric scale and color scale as well, black being none and white being the most. And there's colors in between, like weather radar, you know. And around here, my lights are kind of on the border of yellowish to green, kind of orangey to yellow to green, depends on the night. Out in Wyoming, it was purple, almost black, where I was in town, right, with the lights they had there. If you just blocked out the lights, you could see the Milky Way horizon. I mean, that's how stunning it was.
Right.
And I put up some photos of Devil's Tower, and you can see that it's silhouetted against some lights. The lights are 100 miles away in Gillette, Wyoming. That's the nearest light dome to Hewlett, and it was just stunning to see that. And the photos are there. I wish you could put photos in the chat, but I can't. You know, it's just like doesn't work. But it's beautiful.
Well, ultimately, I mean, from an amateur's point of view, we are learning the truth of the universe around us, and at the same time, we're losing the ability to see it at all. And sadly, most people don't care.
Yeah.
And that makes me sad.
Well, I will say this though, Daryl. This is very important, I think, to for the future. Connecticut has always been big industrial, state. Do this. Okay, you want to do this? Fine, go ahead, do it. And they didn't care about lighting. Well, Connecticut went dark sky, and since 2012, my skies in my location here have gone from bright with no Milky Way to now I have Milky Way on 3/4 of the sky.
Wow.
All right, it's gotten darker, and it's because of the dark sky rules. As soon as one of those lights, the street lights, they're called Cobra heads, that they have that little light that comes down and protrudes below the light fixture itself. Right. Standard Cobra head on almost every American street. Well, that Cobra head, as soon as that dies, the light bulb goes, and it has to be replaced. It has to be replaced with a full cutoff fixture. And
right on.
As this goes and trickles across the state, guess what? It's getting darker here. And, Arizona knew about that years ago. So, Phoenix, there's no hope for Phoenix. But, travel from Phoenix to Tucson and stop in the middle there. And, there's some areas that are actually dark, frighteningly dark. And, I made a joke about not being able to see my hand in front of my face. And when I was in Wyoming, I could. When I was out in the middle of nowhere. And the reason I could was because they were illuminated by starlight. The starlight was lighting everything up, and there were these faint, fuzzy shadows on the ground. It's kind of a blended shadow. And it was the shadow caused by the Milky Way band. It was absolutely unbelievable.
20 years ago, for the local astronomy club, I did a site search out on the plains east of town.
Yeah.
Now, many of the club members had a preference for going up in the high country, up in the mountains. Yeah. They had several dark sky sites. They called them dark sky. But the light domes over Denver and Colorado Springs were getting so bad that they were basically wiping out the whole eastern half of the sky from up there. I did an eastern site search, and I must have driven every back road in southern Colorado between the Arkansas River and the Platte River, looking for dark places where the club goes set up. I found a bunch of pretty good places and a few really special places where there was not a single light visible from the site. That was a long time ago, and I don't know if it's still like that or not. I haven't been to most of these places in a long time now. I knew a guy in the club. He bought a rural property out northeast of town here. He picked this place because there was not a single light visible. It's a sad fact that the local rural electric cooperatives, in an effort to get customers, they would give you a free light to join, their cooperative. They would go out and put it in your barnyard or whatever. What they didn't say was these lights were mercury vapor lamps, and they were zero cutoff lights, okay?
Yeah.
And they also used about 10 times as much electricity as more modern full cutoff light fixtures.
Go figure.
Yeah, and this guy who built his observatory and built his little piece of heaven out in the country, about 30 or 40 miles northeast of town, well, guess what? When he built it, there was not a single light visible. But if you go out there now, it is just a sea of lights. As far as the eye can see, it's those stupid rural co-op electric lights, as far as you can see. And there went his sky.
Yeah. That's when you call the lawyers.
Yeah. Yeah.
Unfortunately, most of them will laugh at you.
No,
Yeah.
actually, there are dark sky lawyers, actually, especially in states like Arizona,
Yeah.
that fight on behalf of the observatories. You know, like in Flagstaff, you know, you have to go through some pretty big hoops to get any kind of lighting on your commercial properties, because they have the dark sky rules, and you got to you can't get around them. You got to do them.
Yep.
Stringent.
And, well, I wish it was that way in Colorado. It's all about the dollar here. Colorado, pardon my French, but we're rapidly turning into California here.
Don't swear like that.
Yeah, yeah. I think we're boring the audience.
Nope.
Yeah. Yep.
That's a satellite coming across there, Mark. You'll see it. Left.
Where is
left, left to right. You should be seeing it coming up on YouTube.
All right.
It's got to be a satellite.
I'm watching.
Keep a watching.
Where is it? Across the center? Across the top?
It'll come pretty much center from the left.
Yep.
Oh, there it goes.
Just
I saw
yeah.
it.
That was definitely a satellite.
That was clearly a satellite.
I need that timestamp for anybody that can grab it for me. I just saw it coming. But, yeah.
Look,
Gorgeous night, finally.
Yeah, I mean, I'm actually looking at this. The sky is relatively clear in terms of the atmospheric turbulence is actually very low.
Yeah, I mean, it's actually picking up. It was a lot lower earlier. It's actually picking up a little bit now as the moon goes down, obviously. And but, yeah, I mean, it's been a great night. We didn't think we were going to, because they were initially calling for that rain down there to turn into a tropical storm of some sort. So we didn't think we were going to get a stream in at night. And then Paul texted me around 2 o'clock this afternoon with a picture of a bright blue sky. I'm like, uh-oh. You know, and then I texted him when I got home, and he's like, "Oh, we're going crater spelunking tonight." I was like, "All right." I was like, "It's on."
Speaking of that, take a look at the screen now, and you see Tycho over there on the right. Okay, that's the one with the rays emanating out, and you see Copernicus to the left. And you look at the ray structure, those whitish rays emanating from these craters. Just imagine. The impact was so large that it literally, the ejecta from these impacts went, hundreds of miles, sometimes 1,000 miles off of that impact site, and then settled down as it did. I mean, this is something that, when you think about it, you're literally looking at large, whole-scale effects on the moon due to impacts, Yeah. And it's just absolutely incredible. And exactly. And when we talk about like the Maria, the seas, so to speak, on this side, the near side, we see these seas like this. On the far side of the moon, we don't have any such Maria except for Mare Moscoviense, which is one little area, and a little bit of Tsiolkovsky, a crater. And that's confined to these two craters. So how come the far side of the moon has all the craters, and the near side has these Maria? Well, we talked about this one night because it has to go back to the formation of the moon. The far side crust, as a consequence of how the moon formed, in fact, also that the Earth was still molten as well, the far side of the moon actually has thicker crust than the near side. And that near side of the moon, being thinner crusted, you actually would find that impacts would generate more magma upwelling and lava spreading across the surface from impacts than on the backside where it was much thicker. Now, the low spot on the backside of the moon, is called the Aitken Basin, Aitken. And the Aitken Basin is like one of the lowest spots. Oddly enough, on that same far side, just farther north of the Aitken Basin, is the highest spot on the moon. And it's actually caused by, in fact, it's higher than Mount Everest by far. And it's actually caused by the initial impact that caused the Aitken Basin. And they think it was part of this wave of energy that emanated out from the Aitken Basin impact, and just caused this ballooning of the terrain. And one of them ended up very high, and that caused this the highest spot on the moon on that backside. So it's the morphology is amazing, and if you look at the moon, one thing you notice is it's actually lopsided. It's not round. It's not nearly a football, but it actually is more of a football type shape. Where you have one side of the moon that is sticking out more than the other side. The north side are less, and the equators stick out more. We don't see that because we don't get the benefit of seeing the moon rotate. We only see it from this one perspective. And that oblong nature is actually what helps it with the tidal locking, help keep it locked in one position to this Earth. So it's really, as you learn about the moon, you learn all these really interesting factoids, and you learn about this stuff. It's absolutely just, it's so absolutely interesting.
It really is weird, isn't it?
Yeah, you take the time to examine the moon and how it was made, and you'll actually see all these things. You learn about the oblong nature, how the center of gravity of the moon is not in the center of the moon. It's actually shifted toward one end of the moon, toward the backside. It's incredible, So I don't know. I just think it's pretty cool.
I always wondered at the different appearance of the ejecta between Copernicus and Tycho, for instance, where I guess you'd say Tycho's in the highlands and Copernicus is in the mare there. Well, the ejecta on Tycho, the snozberries taste like snozberries. It looks like big rays spraying all over the moon. And you look there at Copernicus at lower center, and I said this earlier in chat, earlier this evening, it always looked like a big mud splat to me around Copernicus. The ejecta, the rays look totally different.
Yeah, they do.
Even when you get close on a close-up to Copernicus, it looks like a kid dropped a rock in the mud.
Yeah.
The shoulders of the rim of the crater,
Yeah.
I assume that's just the different materials in the mare floor versus up in the highlands, but that just always made me wonder. It looks like a big splat.
Yeah, it does. And if you look at Tycho, Tycho is in an area where there's a lot of established craters already, and it came and plastered in over them in some cases. There's a number of craters, obviously, that occurred after Tycho. And Copernicus happened, as you said, in that Maria area. However, take a look at the size of Copernicus versus the size of Tycho. They're different size impactors, and they were probably impacted at very different speeds. And that dictated how the ejecta would shoot out from the crater impact.
Right.
But the other thing we have is in an area like the Maria, where there was fairly uniform, homogeneous soils at that point, the lunar regolith and the bedrock. When that impact occurred, there was this liquefaction that goes on. That is not melting, but liquefaction of the soil. Right. Just like if you have a vat full of sand and you put a toy building on it. If you shake that table with the sand in it, the building will sink like it's sinking into quicksand.
Yep.
And that's because you're getting what's called liquefaction of that soil. So when Copernicus impactor hit, it caused this liquefaction, which actually simulated what looked like water ripples coming away from Copernicus, but it wasn't water at all. It was the liquefaction of the soil from the shock impact. And that only lasted a few seconds, and then it was gone. And in that time, these features formed for all time. In the highlands, though, where the terrain is so different, as you pointed out, we don't see the same liquefaction because the terrain is different, and it didn't have this fairly homogeneous area over which to expand the shock wave out from properly in a way that could actually generate liquefacted areas. So on Tycho, we don't see that. We see what looks like a stark crater amongst the other craters. Now, there's probably liquefaction artifacts in the floors of some of the craters surrounding Tycho, but they're also covered and buried by the billions of years of further ejecta dropping down and other impacts causing vibration to sort of basically shake the moon a little bit and cause things that are called like slope failures, right? Slope failures, like on the edges of craters, especially simple craters. The slope will fail sometimes. You get these gullies of material that looks like it's fallen down in. Well, that's from impactors that vibrate the moon and cause it to shake a little bit, and thus stuff fails and falls down into the floors of the craters. That's a large reason why these simple craters are filled with stuff. So it is kind of interesting.
Making you learn tonight, people. We're making you learn.
Not making anybody learn. They can stop if they want to.
Let's see who we got in chat real quick. Let me just shout out the people that are hanging out with us. Participants. There we go.
Good night, Arrow. He's going to bed.
All right. So we got Dapple, and of course we got Daryl and David and Dee and Amanda and ERO and Kev P and Prow and Ted and Weird Guy. That's the active participant list, but we have a lot more people watching and actually participating in the chat. So welcome to everybody. With me is Mark D'Antonio and Daryl.
Hello.
Hey. One thing I learned a long time ago when I was doing public programs, always leave the people wanting more. Okay, exactly. I gave people programs where, they were falling asleep in their chairs, and maybe some are falling asleep here. Who knows? But I learned to cut it off early and leave them wanting more, and that way they'll come back the next time. Folks, it's been a blast. I think I'm going to bow out for the evening. I'll go back over to the chat room, but I'm about talked out, and I'll give you two the floor, okay?
Well,
it's been a pleasure. Been a pleasure talking with you.
Daryl, it was great to spend some time with you. Thanks for coming on.
And I look forward to doing it again sometime.
Yep.
Awesome.
Thanks again, Daryl.
You bet. You take care.
Yep. You too. Great guy.
Yeah. Yep.
I'm not sure how long Paul wants to go for. I just texted him. He said, "I'm chilling." I said, "Yeah, I'm chilling too. We're just sitting here chatting with Mark and Daryl."
Yeah, that's okay. I mean, Daryl's got the right idea. I'm actually going to go to bed early because I'm going to... early for me is before 2.
Yeah.
Because I got to fix my regular machine tomorrow. I got the the computer. I got my laser cutter working right tonight. And I actually did something interesting with it. I actually took an image of the astronaut admiring the American flag on the moon, and I engraved it on a piece of acrylic. And when you edge light it, at the bottom, you actually see the image in a nice ghostly appearance. It's really kind of cool.
Mm-hmm.
So that's another thing I'm going to offer along with the craters is these engraved images and stuff. You can do kids, your family, you can dog. It's really fun.
Sweet.
Does a lot. Yeah, it's cool. But I'm really doing these craters. I got Aristines in front of me, and just from the different light, I can create the lighting as it is. At any time of the lunar cycle, and it's just fun to do that. I don't know, maybe I'm just a little strange.
I cannot wait till we make so people can see these craters that you print out. That's going to be interesting.
Yeah, but as I said, I'm going to put them on the FX Models Planetary Replica page. You're going to see them.
Nice.
And they're going to be offered by P&K Space Imaging. They're going to be offered by us. And no one's going to have them for any cheaper than anybody else. We're not going to be, doing pricing wars.
I'm announcing a sale right now, 20% off. No, I'm just kidding.
Oh,
no,
you son of a gun!
They are definitely something that that especially people that are really into space, really into astronomy, really into the moon for that matter, is definitely something that you definitely want to have. It's just they're amazing.
No, when you look at Aristide, for instance, I mean, you've got the mountains around it, And just by changing the angle to the light, you can just see how that lighting changes, and you see the long shadows appearing off the mountains.
Yep.
And it's actually, we're closing down on a crater-sized area on the moon with some overlap around the outside. It's not just filling. It's not just all crater. I've also got some landscape around it that I include because it looks nice that way. And I've got some things where I printed out that are fairly large scale things. So like Mare Muscoviense, I mean, the craters are all smaller than an 1/8 inch except for Mare Muscoviense, of course. That's very large. That's a far side Maria crater. And the craters are all really tiny. But it's the scale, that I made. It's a scale thing. So it's really interesting to see that, I just love it. And by the way, until you actually print one of these out, you don't really have a good feel for the terrain on one of these craters. Like, I knew Aristarchus had this weird ridge to its west, but you don't really see it and understand it until you got it in front of you, like I have here. And I can actually see this ridge of higher material, and it really drops quite low to its southwest of the crater and drops way down low.
It's surprising. I mean, I was saying the same thing about this crater. You printed me out here, how it has that one crater cut in half. You don't really realize the height difference in the two different sides of the crater until you see it like that. It's really amazing. The amount of detail that goes into these small, 4.5 by 4.5, blocks. It just, you're wondering, I mean, personally, I'm just thankful for the 3D printer. It's something that we're actually able to do this now.
Yeah. Well, and it certainly does take some time to prepare the files. I take them down from the U.S. Geological Survey as just raw height maps. I bring them into a USGS program, in fact, to massage them and work them so that I can actually extract from them and create a stereolithography file. And once I get the stereolithography file, an STL, out of that, I can print that on my 3D printer. So that's really the key here, And by the way, when Heidi was up, she actually took the Rosetta mission target. She took Comet 67P there, Churyumov-Gerasimenko, that we landed on with a Rosetta mission. I actually printed out the whole comet.
Oh wow!
In those two little lobes, and she actually, she took that as her gift that I offered. I offered a lot of things. I offered them all to everybody at that point. I said, "Here, just take anything you want."
Yeah, we walked away with a lot of stuff that day.
You made out better than anybody else, though, because you also walked away with the actual Jupiter 2 from Lost in Space.
Yeah.
Because I had that here. And for those who may not remember, you might remember or hear it and say, I remember that. What was that? And there was a TV series in the 60s called Lost in Space, and it had a ship called the Jupiter 2. And, and you had Dr. Smith, oh no, Will, we're all going to die, And you had, played by Jonathan Harris, and he was famous for calling the robot, remember Robot? XB9 or something? And the robot, he would always call you, out of my way, you tin-plated booby, he'd say, or he had all these little lines for the robot. You terrible tin tabulation, you clumsy clod, and so the ship that was in that show was called the Jupiter 2, and it was basically looked like a flying saucer. Well, I had a guy drive out a copy of it from the mold, from the actual Jupiter 2, drove it out to me from Los Angeles. And he wasn't bringing it because I asked for it. He actually showed up unannounced. And I was I going to say? No, take it back to L.A., And basically, it was sitting in my yard for a number of years. And I didn't know what to do with it. I wasn't going to make it. I knew I actually had several projects with Jupiter 2s to do for other people from established kits that other people made. And I was in no hurry to make a studio scale Jupiter 2. So I ended up giving it to Keith when he came up. And he saw it, and I said, hey, do you want that, Keith? That's the Jupiter 2 from Lost in Space. I thought Keith was going to poop his pants.
It got in the back of the truck, strapped down, and somehow I ended up in Yonkers on the way home
with a flying saucer in the back of your truck.
I bet you that got some looks.
He did, I'm sure. But the thing was, here's how much Keith wanted this thing. He had driven up to my house, and then we went to Bill's later, right? And then we did the Pine Bush thing.
Yeah.
And I had to drive home, but Keith followed me home. And, I couldn't get rid of him. No, I'm just kidding.
Yeah, Mark didn't know until he pulled in his driveway. I was pulling
right. What are you doing here? Oh, I thought I was going home. Hey, you done with that? You going to eat that? Well, anyway, no, we had arranged for him to come by and pick it up. So he followed me all the way back, out of his way.
We're talking New York to Connecticut.
Yep. And then he picked it up, strapped it down in his car, and took off with a smile on his face. And
don't insult my beastie truck by calling it a car.
Oh, did I say that? I'm sorry. Tell your dually truck that it was duly noted that it was a truck.
Beast from the east.
The beast from the northeast. Yes, the beast from southwest of me.
Yeah, as soon as I get that the studio done, that thing, you're gonna see what that thing really is gonna look like. It's gonna be nifty.
Well, do it justice. Make sure that if you're gonna cut out the window and actually add an interior. They actually make a model kit of the XB9 robot, so you can actually have robot looking out of the window. So that'd be pretty cool. And if you don't have one, all you got to do is get yourself an STL, and I'll grow it for you on the 3D printer, and then you can make it that way.
I was thinking about having you make me a couple crater molds on like the 11-inch that you said you could do 11 by 11 or something like that.
Yeah, 11 cube. Yeah.
That way I could make. I was thinking about making molds with it.
Another bird.
So I could. So I can actually put some plastic and whatnot and make a couple. But yeah, we'll talk about that at a future time. But besides that, I can't wait. But as soon as we get on the ball with the things, we'll tell you exactly how to get them and where to go to get them and all that good stuff. And hopefully you guys will pick up some moon craters because they're really neat. And I will do a video on the ones I have here. I think I'll wait for the Jackson one to come in.
I have it boxed up, and I just haven't got to the post office. I've been trying to get my machine and the laser cutter running.
Yeah, that's fine.
Got the laser cutter going. I actually finally, having a laser cutter is kind of a weird thing because you can cut anything you want except metal. Okay, so it's all plastics and so forth and all that. But for a laser cutter to work, it has this long tube. The tube's almost 4 feet long, and it's a sealed glass tube with CO2 in it, and it's a CO2 laser. You can't see CO2 laser light; it's invisible. So if you put your hand in the wrong place while this thing is cutting, you'll literally cut off a finger. It's powerful, and so you got to be really, really careful. And you have to wear polycarbonate glasses because a stray reflection could burn out your retinas. Mm-hmm. So you have to be really careful of that. It's a fairly industrial unit. It's pretty big, but the nice thing is that to get it to work is fairly simple. You just have to supply a little air. So I have a compressor that I have in my shop anyway, and I ran on the compressor line, and I run a little air through the nozzle, and that keeps. It's going to sound silly, but it keeps the plastic or whatever you're engraving on or cutting through from catching on fire. Okay, and then you have to run cooling water through the laser, and that's what the laser has it's a jacketed laser tube, and so water runs through the center, and the laser is actually on the outside, all around it. And when it lasers, you can't look inside the tube. You can't look at the tube when it's lasing or creating the effect because it's a bright purple glow. Yeah. And then what comes out is only 1% of the energy being generated. And that's what actually does all the cutting. So just imagine how much power is actually being generated inside the tube, and only 1% gets out. That's incredible to think about, Yeah. Jeez. And it plunges, it goes through 1/4-inch plastic like it's butter.
Let me ask you, Mr. D'Antonio. Is it too late to open that box up and kind of stick Aristarchus and Pythagoras and Clavius in that box with that other one?
Oh, you know what? I don't have Clavius yet. I gotta actually. I'm talking to one of the guys at USGS to help me with this conversion program, because the file that has Clavius in it is actually is several gig in size.
I bet.
And I have to kind of get in there and parse it out.
That
so
terrain,
I'm having him help me.
Just with all the smaller impact craters inside of it, it has to be so much information.
I know, but that's not it. I mean, Clavius itself isn't several gig. That section of the moon that it's in is a large file, and I have to get in there and figure out how to parse it out. And I'm going to have him help me do it. And he said he would. He said, any questions, let me know.
Any plans on streaming anytime soon?
Yeah, I was going to stream last night, but it ended up clouding up. When I got home from that outing, I was watching someone sing and play the guitar, and it was really nice. But I got home, and it's like, oh, hey, let's go stream. And I went outside, and it was like, hey, it's cloudy now. And then a few minutes later, it was raining. I was like, wow, that was very, very fast.
Nice.
Yeah.
Yeah.
So anyway,
but I can't wait for your
the next clear night. I'll stream on the next clear night. Yep.
Awesome.
And we'll talk and make sure you look on the FX Models replica, planetary replica page, because we're gonna have the photos of the craters up there. You'll see them. And as I said, Keith's gonna offer them. I'm gonna offer them, and they'll be in two forms. You can buy just a plain square, or you can buy them on a nice wooden plaque with a brass plate with the latitude and longitude of the crater and the feature that you're seeing.
That'd be sweet. And I will make a video with the ones that I have here just to show people in detail, up close and everything.
And I have photos. I have photos of the ones with the plaques too. Awesome. So you can see what those look like.
Well, I'll tell you what. I think I'm going to wrap it up here with us. We're still streaming after this, so don't think we're leaving anywhere, people. Mark said that we would talk for about 20 minutes or so, and now it's 3 hours later. So
and I'm gonna go to bed, like I said. So this is cool.
Normal. But once again, jump on over to Mark D'Antonio's channel, the Sky Tour live stream. Get to learning some stuff. Great channel. And if you need your Mark fix, of course you can check out NASA's Unexplained Files and What on Earth. And of course for any of the stuff that he makes with FX models. And I believe he invented the sun at some point, possibly grass. So am I missing anything, Mark?
Actually, I did invent those. Actually, I created a digital. I actually created a computer model of a star because I had to. That was part of my degree. I had to actually build a star, and that was the most complicated thing I ever did in my life, because you had to account for all the physics that goes on in the core of a star, all the way to the outer envelope of the star, and the computer printout that I was doing to generate all this was just literally about 50 feet long, because it literally went from through the star from over a period of kilometers at a time through the star. And of course, when they have a star that like the sun that's 860,000 miles across, it takes a while.
Jeez.
And all the parameters had to match up, and I actually ran into problems near the outside of the star. Because I wasn't handling what's called convection, like in a pot of boiling water, because convection occurs in the outer envelope of the star.
By the way, you don't mind me sending you random questions throughout the day, do you?
Hell no.
I just get this thing. I'm like, I gotta ask Mark about that. And then for anybody that doesn't know, I'll just send him a random Skype message about something totally off the wall that I can't understand, and he'll send me a message back and let me know exactly. What was the last one? I was trying to figure out the difference between what was it? Oh shoot, now I forget. There's something about distances when you're talking about galactic and super galactic or something.
Yeah. It was galactic and super. It was that you were asking what's galactic longitude versus super galactic longitude.
Yeah.
And again, it's like, and for the benefit of people listening now, if you think about the Earth, we have a coordinate system, latitude and longitude. Well, the equator is 0 degrees latitude, okay? And it's got longitude that goes all the way around it. Now, longitude of the vertical lines that run from north to south, latitude of the horizontal lines that go up. So 0 at the equator is 90 at the poles, negative 90 at the south pole. Now, expand that outward now and say, well, galactic latitude and longitude is a latitude and longitude coordinate system that's based on the disk of the galaxy.
Now see, this is where Mark is the man, because both definitions I read, they sounded like the same thing. You know, they weren't
Yeah.
comparative to size, and this is where Mark is an expert because he makes it understandable. So go ahead and tell them the difference between the galactic and supergalactic.
Well, yeah, I mean, in galactic latitude and longitude is just like I said, using the galaxy, the galaxy itself with its north and south pole and its equatorial plane of stars in its disk. Okay, that is the zero. The galactic longitude, latitude rather, of zeros along that disk, and it goes up to 90 and down to minus 90. And then the supergalactic latitude and longitude has to do with and that's sort of arbitrary. That's a perceived coordinate system based on the local cluster of galaxies as a whole. And so there's that coordinate system. Why so many? I don't know, frankly. I thought, galactic latitude and longitude is for the galaxy. Supergalactic latitude and longitude is for the cluster of galaxies. So they're all at all angles to each other. So that's kind of an arbitrary selection.
So it was one of those things I just didn't understand, and I was going to send you about the date too, about how they usually, because they have an elliptic longitude and latitude, and then they have an elliptic longitude and latitude in parentheses. It says on date after that. Now they're pretty much the same coordinates, but they're different by slight decimals, and that's something I'll ask you another day. But I'm slowly learning myself. But once again, I want to thank Mr. D'Antonio for joining us.
Hey man, I had a good time. I
always
hope you guys
a chit chat.
Had a good time. Thank you, Amanda, for putting SkyTour Livestream in the chat. That's very nice of you.
Absolutely. And make sure you guys get over there too.
Join me and Amanda as we do the SkyTour Livestream.
And make sure to hit the bell when you subscribe. Because the way YouTube is these days, you're not going to get an alert unless you constantly go to your subscription page. You'll see it pop up. But if you click that bell, it'll actually send you a message or through your email or however you have it set up. It'll
tell people where that bell is, because even I didn't know.
It's actually right by the subscribe.
And there's a bell there. That's correct.
Yep. And there's this little bell, and you just click that, and then it'll shoot you an email every time either myself or Mark goes live, or Bill, if you're subscribed over there. Don't forget to subscribe to Bill New York Skywatch as well, because we do have the meteor shower coming up starting in 6 days. So that channel is going to become very active in the next week. When he starts shooting that, and that's going to be amazing. And I'll probably be over there a couple times hanging out with him. I'm pretty sure most of the people in the chat. Sure. So it's going to be a good time. So we got a very active fall, very active winter coming up. So I'm ready. I hope you are.
Well, I actually saw my first glimpse of the Orion Nebula the other night, and I just cannot wait to do some deep imaging of the nebula with people. I want to show them what's going on. There's so many, just in Orion alone, there's so many amazing gas clouds and so forth. And I got to tell you, for the first time ever, my SkyTour Livestream audience knows I saw the Veil Nebula, the supernova remnant in Cygnus, which I've never seen in my life until I used this telescope on a live stream and I saw it. And I think people were just hearing me blubber and go on about this for a long time because I was just so impressed with it. I never saw it. And now I also saw something else last time with this telescope. I saw the Horsehead Nebula for the first time. I had never seen that before because it's a dark nebula, only silhouetted by a brighter nebula behind it.
Wow.
And it was absolutely incredible to see that. And it was like, wow, the Horsehead Nebula.
Applause for Paul, because, I mean,
absolutely.
Look at that crater wall definition.
Yeah.
Wow.
He's looking, that's Copernicus, I think, yeah.
Jeez Louise. But anyway, we'll wrap it up. We'll save our voices. We'll let you get off the bed. I'm going to switch it back over to the music. We're gonna just keep on streaming until we decide to call it quits. But once again, thanks, Mark. SkyTour Livestream with Mark D'Antonio. Go over there, click the bell, subscribe, and learn a thing or two. And
I gotta just say one thing. I gotta say one thing to Amanda. And yes, Amanda, I did see your Thunder and Lightning video. By the way, I think you asked me about that. I did watch the video, and I just never responded to that one particular question you asked. So I apologize. Carry on, Keith.
I forgot what I was gonna say.
You were signing me off, so I'll just do it myself. Hey, all right, I will be back again sometime in the future.
Yeah.
And I'll talk to you guys later. And join us on Sky through Livestream if you get a chance. And convince all your friends to subscribe. Don't think I'm too nutty for that UK Sun article they did on me. That was
Yeah, right.
Exactly. All right.
All right, guys. We're going to wrap up the chitty chat, and we'll talk to you guys again soon. And once again, Mark will be on plenty. So, but make sure you jump over there and subscribe and learn something. All right, guys. We'll talk to you later. Peace.
Out.